Hello and welcome back to the multilingual method. Do you know that your brain understands thousands of words every day? Have you ever wondered how you can instantly recognize a speech, choose the right words, and even learn new languages? Today's lesson is about neurolinguistics. Let's start. Neurolinguistics is the study of how the brain processes language. It combines linguistics, neuroscience, psychology, and cognitive science. Neurolinguistics is an interdisciplinary field. It investigates how the brain understands spoken and written language, how we produce speech, how children acquire language, how bilingual brains work, and what happens after brain injuries. Neurolinguistics asks what is happening inside the brain while we speak or listen. Language involves many brain functions such as listening, speaking, reading, writing, memory, and attention. Language is not controlled by just one tiny part of the brain. Instead, many brain regions work together. When you hear someone speaking, your brain first recognizes sounds, then identifies words, retrieves meanings from memory, builds grammatical structures, and finally understands the message. All of this happens within milliseconds. Let's see what happens in the left hemisphere of the brain. For approximately 95% of right-handed people, and many left-handed people as well, language is mainly processed in the left hemisphere of the brain. This hemisphere specializes in grammar, vocabulary, speech production, and language comprehension. The right hemisphere also contributes, especially in understanding humor, emotions, sarcasm, and intonation. One of the most famous language regions in the brain is called Broca's area. Located in the frontal lobe, Broca's area helps us produce fluent speech and organize grammatical sentences. When this area is damaged, people often understand language fairly well, but struggle to speak fluently. This condition is called Broca's aphasia. Another important region of the brain is Wernicke's area. It is located in the temporal lobe, and it helps us understand spoken language and assign meaning to words. Damage to this area produces Wernicke's aphasia. People with Wernicke's aphasia can usually speak fluently, but their speech may contain incorrect or meaningless words, and they often have difficulty understanding others. Except Broca's and Wernicke's area, there are other brain regions where language learning depends on them, such as motor cortex that controls speech muscles, or auditory cortex that processes sounds. Another area is called angular gyrus that helps connect reading, writing, and meaning. There is also visual cortex that processes written words. And the last one is cerebellum that contributes to coordinating smooth speech movements. What is aphasia? Aphasia is a language disorder caused by damage to the brain. The common causes of brain damage are stroke, brain injury, tumor, or neurological disease. Aphasia does not affect intelligence. Instead, it interferes with speaking, understanding, reading, or writing. Studying aphasia has helped scientists discover how language is organized inside the brain. Let's see how scientists study the brain. Modern technology allows researchers to observe the brain while people perform language tasks. For example, functional MRI measures blood flow to active brain regions, or EEG records electrical brain activity with excellent timing, and PET scans measure metabolic activity. These techniques have revolutionized our understanding of language processing. Neurolinguistics also studies bilingualism. Researchers investigate whether multiple languages share the same neural networks and how switching between languages affects the brain. Many studies suggest that bilingualism strengthens executive control and cognitive flexibility, although the extent of these effects varies across individuals and experiences. Let's review. Today we have studied that neurolinguistics explores how the brain processes a language. We also learned that a language relies on multiple brain regions working together rather than a single language center, such as Broca's area that supports speech production, while Wernicke's area is essential for comprehension. We also learned that aphasia is a damage to a brain region. We also talked about brain imaging technologies that may continue to reveal how we speak, listen, read, write, and learn languages. In our next lesson, we will explore another fascinating area of linguistics. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and share it with others interested in language and the human brain.